Eclipses and the Inex cycle is what I'm going to talk about a little bit today. First thing I want to start off with is just got to recap a little bit of what we find in the numbers, the biblical numbers, with how we arrive to some of these values for instance, the 23.5 degree range for our ecliptic right here. So our limits here we assign these to 23.5 degrees. As we know in the biblical numbers, we're given, again, we're to start with Gad's number 45,650. We know that's 913 Bereshit. Okay, so this is the number that gets us down the path of how we get started. We know that when we add Gad with he's grouped with Simeon and Reuben here, the 59,300 and 46,500. We're given this number of 151,450. We know that this number is special because its least value here, 3029, is it's got two factors, 13 and 233. Both of these are Fibonacci numbers. So it's with 233 being the 13th Fibonacci number. And we find this number in other places as well. Once we figure out what the quarter of the circle is. I guess we're asked to find the 1/4 part of Israel. We're going to assign this quarter piece that we're given. Moses is the one that counted them. We just got to find it. So when we multiply this by 4, we get 605,800. Of course, this is a difference of 2250 from our given total. All right, so this is what we're going to assign the value for Levi in the first census. And then, of course, in the second census, if they have to stay 605,800, we're going to add the difference of 1820 to him because we're told that the value of the second census is 601,730. So we have to keep it at 605,800. So 601,730 gets us to 4070. Why is this significant? Because if we multiply this times phi, we know we're going to hit our eclipse range, 6585.39. So probably not coincidental. If we divide this by the square root of 5, we're going to get 1820, which we know is the difference between the two censuses. We multiply this by 2 to get our star pattern number, 364. Divide this by phi again to get back to 2250. So probably not coincidental. So once we get, again, for those that aren't familiar with how we get phi, we'll just clear this out. We're going to take the square root of 5. We're starting with this value. We're going to add 1 to this and divide this by 2. And that's going to be our number for phi. We'll just store it in our calculator right here so that we can use it later. So now another value that we want to be aware of is pi, of course. Those that follow Project 314 be well aware of how we get this. If not, I encourage everyone to get that book, House of El Shaddai, and find how we find this and how that factors into everything. But when we divide pi by if we divide this value by 12, again, we're going to see that we're going to get this pattern of numbers right here, 0.2618. So we know that this is going to be, essentially that's going to be phi squared. So if we take phi and we multiply it by itself, we're going to get the same as phi plus 1, 2.618. So we see that the same pattern of numbers right here showing up. If we were to, I just divide that by 10, and now if we multiply this by 12, you see that we're getting pi. If I were to subtract pi from this number, you see how close it is to the actual value of pi, very close. So phi squared and pi are going to be relative in these numbers. So again, 605,800 is our found total number, and we know that we divide this by 4, again, this is our given piece of the 90-degree piece in that first census. And so, again, when we find those bifurcations, we find all of the significance in the Judah South portion. So Judah gets broken up across the east compass line when we set Reuben right on the south compass line and Gad on the west compass line in that first census. So what we do is when we work backwards, we're going to subtract Zebulun's value here, 57,400. Takes us down to this value, and then we're going to subtract from this. We'll take Issachar's number of 54,400 off of this. And this is going to get us the remainder of that quarter piece is this 39,650. Again, remember that, oops, clear that off, messed that up. Again, our quarter piece here is 151,450, and we're going to subtract from this. It's going to be we subtracted the combination of Zebulun 57,400 plus Issachar 54,400, and we saw that this value right here is 111,800. If we divide that by 50, again, 2.236, that's the square root of 5. So if we were to square that value, we would see we'd get very close to 5. So when we take this and we take this away from that quarter piece again, we're at this value, 39,650. And this is significant because once we look at what this percentage is of the total, remember our total is 605,800. We see that we're at this value right here, which is 6.545% of the circle. But we know that we're working in degrees, so when we multiply this by 360, we see that we're 23.562 degrees. Okay, so, and we recognize that this is going to be sort of our value of that ecliptic range. Okay, so this ecliptic range right here, 23.5 degrees. So we'll get this back into our percentage value here, and we know that we make this travel 4 times. So from your equator, or your celestial equator, to your limit, to the equator, to the limit, and then back, 4 times you make that movement. So if we multiply that by 4, again, we're seeing this same pattern of numbers. Right? We're seeing this phi squared pattern divided by 10. And then we know that if we multiply this then by our quarter circle, we're going to get 39,650. So this value right here is significant. 605,800 times, we're multiplying this by, again, the 360 degrees to get this into a degree value. So 23.562 degrees. If we divide this value by 9, okay, we're going to be right at phi squared. So how is this relative? Well, we want to look at, to see how this ties in, we just want to look at the analemma of the sun. So we know that the sun, however we're going to look at this analemma, or the range of the, there's all different ways that we can look at it. We can look at it this is a cylindrical projection to look at this, the movement of the sun across the ecliptic path here is going to be a sine wave as it's hitting its solstice to equinox to solstice and back. So we have a sine wave pattern in this projection. In this projection, a polar projection over center north, you have your equator here in your tropics, so you're looking at a snapshot every day, the movement of the sun over this path, and you're seeing how it's making the circular path like this here. So this would be a sine wave path on the cylindrical, circular path on a polar projection, and then of course this in this globe model right here. This helps us by looking at a particular meridian and then taking our snapshot, and then from one particular place we can see how we're moving along this path. So where we March, April. So you're going in this direction just like this. You're just going to be tracing this path around from limit to limit. And of course you have this crossing that happens at 9 degrees. So how does that help us? Well, we know that, again, our value for this was our degree value, 23.562 degrees divided by 9 gives us phi squared. And the crossing happens at 9 degrees. So what we can do is we take this breakup right here, and you see how we have these values assigned. So we have 9 degrees here with another 14.562 degrees. Gets us 23.5 or 23.562 degrees to from our equator to our tropical our tropic there, and then the same distance from the equator to the other side, and that gives us these other values again from the range from the crossing. We got to look at this as other values. So there's this other value that we have in degrees from the crossing to this solstice, and the crossing to the equator here, and then the entire range of being 47 and an 1/8 degree. So if you were to wonder what 47 and an 1/8 times 8 is, well, we're up to 377. Okay, that's the number just past 233, right? That's your next Fibonacci number. So 233 is your 13th, 377 is your 14th. If we divide this by phi again, 144 is our 12th Fibonacci number. So so that's interesting that you're using a 360 degree pattern right here, but the numbers are in line with your Fibonacci numbers as far as if you multiply this value out by 8, which would be a difference of 17, and that's kind of interesting, 360 to 377. But at any rate, if we reduce these values by 9 here, we'll see that when we boil this down, this is going to be our base. Our base sort of relationship. So, we're assigning a value of 1 because we're reducing all these by 9. So a value of 1, and then a value of phi, and then a value of phi squared for half of this thing, and then a value of 3.618. Phi squared plus 1 would be this value. And then that gives you a value of 5.236, or phi squared times 2 for the entire thing. And then you'll notice that this value right here, this 3.618, is the same as if we multiplied phi times the square root of 5, we would get 3.618. So all the relationship of this analemma is very interesting. And again, we get this based off of our understanding of the biblical numbers and finding that number of Judah south and making this association of 23.562 phi squared times 9. So all that to say, what does this mean for eclipses? Well, we've already found that 4070 number for Levi in that second census times phi gets us into the number of days in between eclipses on a particular Saros. And so what is that? Well, first we need to look at, real quick, we're going to review the movement of these luminaries. So one of the base luminary that we need to look at is going to be the stars, the movement of the stars. So on this polar projection, as we're looking down here, and we're looking at the movement of our 3 base luminaries, these are all going to be turning clockwise. And so what happens is the stars move faster than any of the other luminaries. The sun is moving a little bit back day per day, and over a course of a month it's going to fall back so far on this ecliptic path amongst the background stars. Now the moon is going to be so much slower that it's going to fall all the way back around this ecliptic path all the way to that same position in a month's time. So it's going to make this whole travel around in the time that your sun made that 1/12 of the circle. The moon's gone all the way around, right? So, and then the moon is also going to be drifting off of the ecliptic, so off of the same path that the sun is cutting through here. It's going to be drifting off up to 5 degrees inside to outside. And when it crosses over that path, it's called the draconic cycle. So as soon as it crosses over and is equal with that ecliptic path, that's the draconic, that's 27.212 days. The sidereal, at the point where it gets all the way to the same point again, is 27.3216 days. And then of course we all know the synodic phase is 29.5 degrees. So regardless of its synodic phase, it's going to end up in this, it's going to cross over, it's going to have its draconic and its sidereal cycles regardless of whatever the phase of it is. So yeah, we got to understand the cycles or the phases of the moon, and we're seeing the cycle of the sun. Now, the tricky part is going to be these stars. So when we look at, I've got this other video for us to verify and see sort of how this is happening. So when we're watching this, again, this is set at the equator right here, and we're going to watch the movement of the stars. You see how we got, we're Leo here, and then it's presented to us Virgo, and then it's going to be Libra. So again, these are moving in this direction, and they're being brought out. The scroll is being presented to us in this particular order, and again, the sun here is going to fall back day by day. It's going to fall back from the speed of these. So let me get this out of here. So this creates a problem for us here because, again, we're getting presented in this other order, so the flow of this seems backwards. Because, we're looking at everything just as we're going to look at a projection of our map, a cylindrical projection of our land map. We're looking at everything coming from the east to the west. Everything's traveling this direction, from our right to our left. However, this projection right here, you see that our time is moving from the left to the right. So this is because we're looking up at the stars. We need to think of this and look at this in a different way. So what we're going to do is we're going to flip this horizontally so that we see that the scroll is going to be presented to us in this particular direction, right? So, and now we can start to see and better understand how the sun is falling back from Leo to Virgo to Libra over the course of time, right? They're all going to be traveling together at this particular latitude, but we're just looking again at snapshots as it's falling back ever so slowly, and then we're going to be looking at the moon making this journey backwards over the course of a month, making an entire movement and then drifting across the ecliptic at that draconic cycle as well. So what that's doing is, you're going to get these eclipses form. And so on a Saros, the eclipses are happening every 65, 85, and a third days. So that's 18 years, 11 days, and then 8 hours, which is a 120-degree shift. And so what you see here is this is all the eclipses on this particular Saros. So every time that you're moving this 65, 85 and a third days, just like we're moving from November 20th, 2027, 18 years later, we're up to, where would we at? 22, maybe, okay, that's the last one on this. So, isn't it? No, right here, 22, 25, December 1st. So, you know, you're seeing how you're shifting that 18 years, 10 days, and then 120 degrees. So, you know, it can start to make sense, I think, to see how this happens, Saros to Saros. So if we overlay this, again, we see that if we overlay this on this other Mercator projection right here that I've set up. Dang it, Jim. It's kind of crazy. You see how, you know, where we can gauge our equator is. So these are all happening in this what we're going to call the northern hemisphere, the inner hemisphere, or whatever we want to call it, right? So you see how they're all happening up here. So we're going to bring this over and we'll just overlay it and put our patterns right here just to give us an idea of kind of where our land features are going to be relative to all this. And so now we can kind of get an idea of what's going to be happening relative to the ecliptic here. So again, all of these luminaries are traveling the same direction. It's just that they're falling back. So say we're looking at this December 22nd, which is probably, you know, that's right near the solstice. So the solstice, we know that the sun is going to be way down here, right? It's going to be down here towards the peak of its movement. And we're going to be there all day. We're going to be at that latitude all day. And then we know that the moon is going to be happening on its draconic. It's going to be crossing the draconic at about the same time. But it's going to be moving much faster, right? It's going to be moved quite a bit faster than the sun backwards. And so you can see how we're getting that same, we're going to be getting that shape. We're going to get this big trough shape right here because we're at the base of this thing when it's doing the crossover. And then, so some of these other ones say it's happening in September or something. So once we're advanced and we're up closer to the actual equinox and this is happening, you see how you're getting this other shape. You're getting a much more vertical shape in your sine wave here as you're crossing back over and creating this path. Now the lunar eclipses are going to be like an inverse to this. Like the solar eclipse, you're only going to see in this one path, whereas the lunar eclipse, everybody's going to see it. So that's kind of your Jacob and Esau thing happening again with Jacob getting the birthright and the blessing, the volume of everything, and then Esau just being that the dew point and the fat of the land. He's the hunter and the consumer. He's that break point, sort of like in your just like we see in magnetism, the plane of inertia, sort of the break point between the thing that's cutting night from day, all that kind of stuff. And you know, if anybody hasn't looked at some of those other videos that I've got up, but yeah, red shift, blue shift, and you can kind of, you know, I did this and broke it side to side so that you see it sort of the red shift side of what you get in the blue shift side, and then you got to pair these up and then sort of index them. So you can kind of start to see how you're getting these quadrants. And this is why the phi is so important, because you know that it's phi to 1 from blue shift to red shift on these, and then you got them paired up. So you got phi squared essentially to 1 over phi squared, or some version or variation of this, and then you know that it's that dislocated hip of Israel. You know that this is giving you that 23.5 degree shift, and that must be what's creating your like I said, this other value in your moon image being projected up or whatever. But at any rate, getting back over to the eclipses, I'm sorry, got off on a tangent there. But where were we? Oh, the falling back. So you're getting these shapes. So these particular Saros cycles are all grouped but there are other cycles, and there's another pattern of what this happens at, and it's called the Inex. And that Inex cycle happens just under 29 years from this period. So like you're going to start one eclipse, and then 29 years later, what you're going to have is you'll have, say, for instance, this eclipse right here will have it'll have a sort of mirror on in the other hemisphere at that latitude. And so, let me see if I've got that figure up. So, on this eclipse pattern right here, so I think I picked this one out right here, like November 20th, 2207. And this happens, the number of days ends up being 10,571.95. Which again, our from Saros to Saros was 6585.331. And we know that 4070 times 5 is the closest number that we can get to that. So we find that interesting. But we know that this divided by, it's 223 moon cycles, synodic moons. And we know that there's 235 synodic moons in 19 years. And then we know that there's 254 sidereal moons in 19 years as well. And of course 254 minus 235 is 19 as well. So that means that the ratio of those is, I don't know if I need to get down this path today. I talk about, I'm not going to get into that right now. Anyway, you'll just know that it's equal to 42 divided by pi, but I'm not going to get into that right now. So anyway, this is our distance between Saros cycles, and this is going to be 223 synodic moon periods. We know that if we divide this number by 29, the same value, it's going to come out to 358. So 358 synodic moon periods in this other cycle, which is this is a, what do you call it there? This is called the Inex cycle. So say we've got this this value right here, 20 November 2207, which is a Friday. So what we're going to do is we just take, if we can format that and then change, once we got that as a date, if I can figure out how to work Excel here, we can format that and change it to just a number, and that's going to be this number. We're going to subtract this number of days from that, so equals this minus this number of days, and that's going to tell us Wednesday, December 9th, 2178. So now all we got to do is we just come over here and we're going to Google Eclipse December 9th, 2178, and that's going to come up as, where are we at? So it's in Saros Series 135. Saros Series 135, again, remember this was Saros Series 136. So it's, I guess, would be like the one that started right before this one. And so if we look at the pattern of this one, I think I found something on this. It's right here, Saros 135. And it's kind of hard to see this, but yeah, it says like July. So July time period. So you see how you're kind of you're in the other hemisphere. So you're at the other hemisphere, and you're seeing how this, relative to this eclipse right here, was this one right here, November 20th, 2207, is this right here. And you see how, yeah, that would be like this eclipse happening in here. So at any rate, yeah, you're seeing how it's directionally it's different because it's in the other, it's happening in the other hemisphere, so to speak. So pretty interesting there. You're going to look these up. I know that some of this fruit is going to be coming from sources that people aren't really going to be very trustworthy of, but yeah, I think it's good fruit. Like I said, we see that this happens. This isn't. This is observable. We see that this is happening. These are predictable. People go out and observe these things, so we know that this is good data. We can trust this. This is good. We just gotta put it in terms of how it's actually going to be happening, or put it in other terms instead of just the physical. We got to start looking at the metaphysical and sort of the electromagnetic, how this is happening and taking place. But where was I going with this? Oh yeah, so the difference. So one thing that you'll note again is going to be the difference. So this 10,571.95, as it turns out. So you'll notice that 10,571.95. If we divide this, we're going to divide this by phi. And then now we're going to divide it again by the square root of 5. You see we're going to get this number right here, 2922. So again, we're dividing it based off of, remember the Inex goes from one hemisphere to the other. So we're going to one side of this, sort of your crossing point, to the other side of the crossing point. And that number divided by the ratio of the analemma right here, the sun, 3.618, gives us 2922. Well, who cares? Well, if we divide, we know that that's that 8-year cycle. So that 8-year cycle of the sun to the 13-year cycle period of Venus is going to be this 2922 number. And I do find this in values of, I think when we start adding up, I want to say it's all the children of Leah. I don't know where I have that thing at, but I'll have to dig that out, where you find 2922 in these values. But I did come across this, and some people will say, well, that's just a given because you're just you're just looking at, essentially you're going to be looking at your Fibonacci number, or your series, which is going to be, we'll just do this real quick. We'll run this down and create a sequence, and then we'll carry this over here, and then we'll change this to Lucas sequence and number this 2, 3. We'll number this so that we see that we're essentially going from 8 years to 29 years. So essentially, you could just say, well, you're just taking, that's obviously it's coincidental because you're going up by phi and then across by the square root of 5, because we know that the relationship of the Fibonacci series to the Lucas series is a multiple of the square root of 5. Then we know that as we're going down the sequence, it's by phi. Like if we all of these, it doesn't matter. Those that don't know, you're going to have that phi number once you get here. But when you're up here and you're looking at the difference between these numbers, you're not that close to phi. And if you're going to look at divided by 8 here, you're not that close to phi times the square root of 5. 3.618. You're off by a little bit. So if you were to take this number times 2922, you're missing that by what was it, 10,571.95. So you're going to be off by 20 days. So it seems kind of significant to me that you're going to be taking this number times I'll just put the square root of 5 in right here. You're going to be taking this number divided by, excuse me, this value here to get back to that 2922 number. So yeah, I don't know. It's I thought it was kind of interesting that came out that close. You'll have to let me know what you think, but yeah, hopefully this is helpful to anybody that maybe isn't up on like the what have you, the eclipse cycles and kind of how those all work. But hopefully you enjoyed that, and we'll see you on the next one.